Okay, so in this video here, we're going to just do a crash course review in C programming. Now, what I have opened up here is not the full application. It's actually just a C window of the software we're going to use. And I'm doing this just because for syntax and purposes like that, we can often see that it's going to help us by auto-completing things. So for instance, and the yellow there means that just showed up there just means I've made changes and they haven't been saved yet. Um, so let's just remember here, let's say we have a function, actually main usually returns, I'll have it return an int. So we know that we usually have our main function here for writing a program. And that's going to be the same thing when we're doing it in an embedded program application as well. We're going to have some main function that we store all of our code in. Now, remember, typically what we do to start with is we define our variables that we might need in the program. So, for instance, we talked about this in the other video. We might have int data1. Now, remember, one thing you can also do, data2, is you can initialize these variables to have values because right now when I define int data1, there's going to be some value stored there in the variable data1. It's just we have no idea what the value will be. By doing int data2 equals 0, of course we know the value initially in data2 is 0. So let me go back here and just predefine a couple things here. Int data3 equals -5, int data4 equals 2. And then of course we could have other things like float data5 is equal to 3.14159. Yeah, it's a little bit like pi. And you can see I actually have an error here. I forgot to put a semicolon at the end here. Now when we actually start getting to write code in the software program, you'll see that it actually helps because oftentimes it will indicate to us that, hey, there's an error on that line. So I have declared my variables, and then you might have some code here, like a simple thing if I want to add, say data2 is equal to, and then I have data1 plus data3. We know that that's going to simply add these two values here, and that after this line of code gets executed, data2 is now going to be storing the value -1. I mean, that's pretty obvious, pretty clear. We can do other things here, like, well, let's go ahead and look at something here like this. Let's say here, I'm going to put in another float here. I'll say float data6 equals 0.0. And there's a reason why I'm doing 0.0 with a float. We'll talk about it in a second. And now I want to do something here just to kind of see what you might think would be the answer here. And I'm going to make one other adjustment here. Let's make this +5 just for easy sake here. Actually, let's make it, yeah, +5 is fine. So if I were to do something like this computation, data6 is equal to, let's see here, let me make sure I do it right, data3 divided by data4. Now, most of you might say that, hey, if I do that computation, I'm going to simply get 1.25 because that's what 5 divided by 4 is. And you're correct that 5 divided by 4 is 1.25. However, data6 is going to store 1. It's not going to store 5, it's going to store 1. And that's because of data types. We talked about this in the previous lesson. Data types are very important. Data3 and data4 are both integers. So when you do 5 divided by 4, it's going to do integer division, meaning it's going to do 5 divided by 4 and get 1.25, but it's say, well, these are integers, so I ignore the decimals. I don't keep those at all. So I'm just getting 1 as an answer. And so that's clearly a problem here. And so that's also where something that we have to be careful of when we start doing computations and having different data types. We have to be very careful with this. One way to solve this is by doing what's called casting your variables. So by putting a float in front of data 3 and a float in parentheses now in front of data 4, what we're doing is we're saying, okay, yeah, I know data 3 is an integer, but treat it as if it's a float instead. So what it's now doing is the compiler is going to say, okay, data 3 is 5, but I'm going to treat that as a decimal number, 5.0. And that's why I like to do 0.0 for floats, because again, reminding myself that these are decimal numbers, not just integers. And then it's going to do the same thing for 4s. It's going to say, hey, that's 4.0. And so then it's going to do the division, and you will get 1.25 stored there. And actually, when we do our first example here of code, maybe I can, that we compile, I can show you that when we debug it here. Okay, so then let's go on here and so these are just basic assignment operators and everything. Let's go through here and remind ourselves of some other syntax here. So if we want to do an if statement, we might, for instance, say if data 1 is less than 3, and then what we have here is we put curly braces here, and then if data 1 is less than 3 here, I'll put do some code. I mean, I'm not going to bother writing any code in there right now. And then you could also have an else statement saying, now it's not required to have an else statement, but we could, and we could say do some other code. And clearly this is just a matter of, well, you know, if we have different things we want to do based off of different conditions, we can use these if and else statements to determine when I should do some code or when I should do other code. And so these are just the basic syntax for it. Now we also have one other thing that some of you should be saying, well, you also have something like an else if, and you could do data 1 is less than 3. And I'm going to compound this here with 2 vertical lines. Do important stuff, I'll just say. Now, again, if we look at this should be familiar with us. Again, this is just a quick review of syntax. I'm not teaching this to you firsthand. This should just be a review. If this seems confusing to you, then you need to get a textbook on C programming or search the web and really do a lot of homework and practice problems on writing C code, because I'm assuming we all understand this. I'm just reviewing some basic syntax. And so here we have, of course, an else if, and this is data 1 less than 3, and these 2 vertical ones we know, of course, is an or, data 3 is less than 3. Now we know with an or statement, only one of these 2 things has to be true. So if we were to look at this code here, we could say, okay, well, we know that data 3 is not data 1 is not less than 3 because it's 4. So this is a false statement. And data 3, well, data 3 is 5, but 5 is not less than 3. Sorry. And so this is also false, so I don't get to execute that. But if I were to change this to, and I'll do this here because we should again be familiar with this, greater than or equal to 3, clearly now this statement is true that data 3 is greater than or equal to 5, and so I'll do some important stuff. The last 2 structures that we'll use in programming quite a bit are the for loop and while loop. Although actually we probably won't really use the while loop too much, so I'm not even going to bother reviewing the syntax for that. So this is a for loop, and notice that I've got 3 things there. First off, I didn't bother declaring, and sometimes this is what people do. I personally always like to declare my variables always at the top, but sometimes you're like, oh wait, I suddenly realize I need a for loop, and so I'll just declare the variable right then that I need. And often I is used for a counter variable. And of course, typically we initialize at 0. You don't have to initialize at 0, but that's typically what we do. Of course, it all depends on the application or what the problem is you're trying to do. And then we run this loop until I is less than or equal to 5, and then I++. So what we should think of here is for a for loop, it's basically our counting variable, I'll say, our condition, and our increment. Because the mistake people think is that you have to increment by 1. You do not have to increment by 1. And I++, of course, is just a shorthand. I++ is just a shorthand for I equals I plus 1. So instead of having to type in I equals I plus 1, we just do I++. But you could, for instance, we could do I equals I plus 2. I mean, there's no reason why we couldn't increment by a factor of 2. It's just not commonly done. The most common course is I++, and that's typically because you're trying to run through a list of something, or you're trying to do something sequentially. So there's, most of the time we don't encounter the I equals I plus 2. But it does show up in programming where you don't necessarily increase your counter by 1. I have written code for simulations a long time ago. Gosh, it would have been in my master's degree. I'm going to show my age here. It'd be 20 years ago that I had to have some counters that were not doing I equals I plus 1 kinds of stuff. All right. Now, one last thing here before we end this video. The next video, I'm going to give an example of code, and then this is what's going to be on the next assignment, and you will absolutely see this on the first exam, is I'm going to give you some code, and then you're going to have to figure out what the end result would be based off of the code. Okay, so let's go ahead and do this here. The last thing I want to show you here is, actually there's two things in this video. How many times does this loop get executed? Now I'm going to just tell us the answer pretty quickly here. You might want to pause the video and see if you can figure it out yourself. The answer here is it gets executed 6 times. Because I start at 0, then I go to 1, 2, 3, 4, and 5, and I is less than or equal to 5, so just because it's less than or equal to 5, when I hit it at 5, I will still execute the loop one more time, so it gets executed 6 times. Now, a very important thing to remember, and that's what's key on this condition, if we had instead int I equals 0, comma, oh not comma, semicolon, I less than 5, semicolon, I plus plus, this loop gets executed 5 times. Now, the last thing I want to show you here is something that looks a little bit odd here for a second. This is perfectly valid syntax for the compiler we'll be using. And we'll have, of course, code in here, code doing something. How many times does this loop get executed? And the answer is, you might want to think about it for a second. I'll let you think about it for a second. If you want to pause it, I'm taking a sip of coffee. The answer to this is infinite. So this is an infinite, if I can spell infinite correctly again, I didn't even spell correctly the first time, infinite loop. And you've probably been told in programming, and what you were told was correct, that infinite loops tend to be bad. We don't want them, right? Because then the program's just stuck doing something. However, with embedded processors, we want an infinite loop. In fact, our code is always going to have an infinite loop in it. And the reason is with a typical application of an embedded processor, you want it to always be running. For instance, just think of when you turn your car on and you have an O2 sensor that's going to be sensing how much oxygen is getting into the engine and everything. Well, you don't want that just to execute once and then be done. You don't want the O2 sensor code to be executed once and then done. You want that O2 sensor code to be executed as long as the car's on. In other words, as long as there's power to the processor. So in other words, how many times are you executing it? You're executing it an infinite number of times. So we're going to have inside our main programs, we're always going to have an infinite loop sitting in there, which is a little unusual at first, but then when you think about it, as in the example I just gave, it makes sense. Now, let's talk about the exam again next week. You need to be able to write down proper syntax for if-else statements and for loops, and explain the syntax. And quite frankly, you can use the exact same example we just did here or something similar to it. If I say, explain the syntax for if and else statements, the easiest way to do that is to put a little bit of a couple variables here and then just do some conditions here. You don't even have to do the or the and. You just have to be able to explain, well, hey, I have an if statement. This code under this first if statement is only going to be executed if this variable is less than 3, so on and so on. So you need to be able to explain that on the text, on the exam. And that's going to be the same thing with the for loop here. So you'll say for is the counting variable, condition, and then the increment, and then you should be able to tell me how many times this loop is going to get executed, things like that. But you need to be able, I could have a question on basically saying, give the syntax and explain how to use an if statement, something of that nature. And the same thing for the for loop. All right, this has got a little bit long here because I got, jabbering and talking. There's one more video we're going to do here, and this video is going to be basically an example of code, and then we're going to dive into the microprocessor. Now, I will tell about the microprocessor in the next video as well.